Hello everyone, and welcome to the Recommender Systems lecture. In this lecture, we're going to discuss the different types of recommender systems and how we're going to approach creating a recommendation system with Python. Let's go ahead and get started. As far as a reading assignment, there is no section on recommendation systems in the Introduction to Statistical Learning book. So in case you are further interested in recommendation systems and what we're going to cover in this course, I suggest you take a look at the textbook Recommender Systems by Janik and Zanker. It's a really great textbook on this topic if you want to get a deeper understanding of recommender systems and the mathematics behind them. Let's go ahead and discuss how we're actually going to approach recommender systems in this course. A fully developed and deployed recommendation system is actually extremely complex and resource intensive. Because of this, we're going to have two notebooks for this section of the course. We have the Recommender Systems of Python notebook and the Advanced Recommender Systems of Python notebook. Since a fully implemented recommendation system actually requires a heavy linear algebra background as far as knowledge is concerned, the Advanced Recommender System notebook is provided as an optional resource for you. You should only take a look at this notebook if you feel comfortable with advanced linear algebra. What we're going to do for this course is show you a simpler version of creating a recommendation system using item similarity for the project. Let's go ahead and give you a light background on recommender systems theory in general. The two most common types of recommender systems are content-based and collaborative filtering. Collaborative filtering produces recommendations based on the knowledge of users' attitude to items. That is, it uses the wisdom of the crowd to recommend items. You can think of this as something like Amazon, where based on other people's shopping experiences, Amazon will suggest items that it believes you will enjoy. Content-based recommendation systems focus on the attributes of the items and give you recommendations based on the similarity between items. So the basic difference here is filtering based on user preferences or filtering based off of the similarity between the items. Generally speaking, in the real world, collaborative filtering, or CF, is more commonly used in content-based systems because it usually gives better results and it's actually relatively easy to understand from an overall implementation perspective, provided that you have that linear algebra background. The collaborative filtering algorithm actually has the ability to do feature learning on its own, which means that it can start to learn for itself what features to use when recommending certain items. CF can also be divided into two subcategories: memory-based collaborative filtering and model-based collaborative filtering. Now, if you feel comfortable with advanced linear algebra, in that advanced notebook tutorial, what we end up doing is implementing model-based CF by using singular value decomposition, and memory-based CF by computing cosine similarity. For our implementation in Python that we're going to walk you through, what we will do is create a content-based recommender system for a dataset of movies. This movie dataset is usually a student's first dataset when beginning to learn about recommender systems. So you may have heard of it before. It's called the Movie Lens dataset. It's actually quite large compared to some of the other datasets we've worked with, but in general, recommender systems in real life usually deal with much larger datasets than this one. There won't be a full exercise of questions for this topic. Instead, what you'll have is the option to work through the advanced notebook if you feel like you have the necessary linear algebra background. There's lots of text explanations in that notebook, so there won't be a video guide through that notebook because it's not relevant to everyone given the background required to actually understand the mathematics in that notebook. What we're going to go ahead and do now is get started with our own Python implementation and walk through an example project using that movie dataset to actually provide recommendations based off the similarity of movies. Let's go ahead and get started. I'll see you at the next lecture.